Welcome to the introduction of our project title, Recycling of Lithium-Ion Batteries. What happens to a lithium-ion battery when it reaches the end of its life? Sadly, most end up in landfills, leaking toxic chemicals and wasting precious resources. But what if we could give them a second life? In my final year project, we set out to do exactly that. By recycling expired lithium-ion batteries and recovering valuable materials like lithium, graphite, and polypropylene film. The first step was extracting raw lithium, graphite, and separating the polypropylene film from expired batteries. Through meticulous cleaning and chemical testing, we verified the exact composition of these materials, critical for ensuring purity and performance in our recycled battery. From background research and literature reviews, we identified cheaper and more sustainable electrolytes for our lithium iron oxide and graphite pair. By previous research, sodium chloride, NaCl, and sodium hydroxide, NaOH solutions showed promising results, enabling efficient charge transfer while being environmentally friendly. For our first prototype, we used aluminum and copper films as charge collectors, layered with recycled lithium iron oxide and graphite. We poured a carefully measured NaCl NaOH solution as the electrolyte and reinforced the cell with glass slides for stability. The poly film acted as a separator, preventing short circuits. The initial results revealed areas for improvement: low charge retention, electrolyte leakage, and weak terminals. But every setback was a lesson. We doubled the separator thickness, improved insulation, and switched to a dry electrolyte formulation. These refinements significantly boosted performance. Recycling lithium-ion batteries directly contributes to several United Nations Sustainable Development Goals, SDGs, by addressing environmental, economic, and social challenges. Most relevant SDGs for our project. 1. SDG 7. Affordable and clean energy. Ensures efficient energy storage from recycled materials, supporting renewable energy systems. 2. SDG 9. Industry, innovation, and infrastructure. Promotes sustainable industrialization through eco-friendly battery recycling technologies. 3. SDG 12. Responsible consumption and production. Reduces e-waste by recovering critical materials, graphite, and enabling a circular economy. 4. SDG 13. Climate action. Lowers carbon footprint by minimizing mining and landfill pollution. 5. SDG 15. Life on land. Prevents soil-water contamination from hazardous battery waste. After multiple iterations, our recycled battery achieved performance close to industrial-grade cells. This milestone proves that sustainable alternatives are viable, and that we can reduce reliance on virgin materials while cutting costs. This isn't just about recycling. It's about closing the loop in energy storage. By these techniques, we can power a greener future. Imagine a world where every expired battery gets reborn, reducing waste and pollution. Join me as I dive deeper into the science, the struggles, and the breakthroughs behind sustainable battery recycling.